Welcome, focused learners, to today's Explainer. We interact with our digital devices pretty much constantly, right? I mean, all day, every day. But today, we are going to completely pull back the curtain on computation. We're taking a deep descent down into the bare metal of our machines to uncover what is arguably the grandest computational illusion of the modern age. So prepare to have some of your most basic assumptions totally challenged.
Okay, let's dive into this. Here is our roadmap for today. Number 1, the grand computational illusion. 2, the von Neumann bottleneck. 3, the FPU gambler. 4, the wood chipper effect. 5, the exact ALU surveyor. And finally 6, forging forensic accountability. Let's get right into it.
I want to kick things off with a question that might honestly shatter how you view your phone or your laptop. Do computers actually process meaning? Think about it. When you type a prompt or ask an AI a complex question, we intuitively feel like the machine actually understands the meaning of the symbols we're feeding it. But is it truly understanding us, or is it all just an incredibly elaborate trick?
Section 1. The Grand Computational Illusion. Blind to human meaning. You see, the reality is that down at the foundational level, the machine is utterly blind to human meaning. It doesn't understand your intent at all. Literally, not even a little bit. Down at the metal, the processor only understands pure physics, specifically physical resistance and voltage. That's the whole shebang.
To really put that into perspective, get a load of this number: 80 to 90%. That is the staggering percentage of modern AI compute cycles that are actually just hardware-level approximations. Wrap your head around that. When large language models are doing their heavy mathematical lifting, they aren't giving you exact mathematical truth. They are fundamentally just guessing the nearest answer. It's basically a giant estimation system hardwired right into the physical reality of our server farms.
Section 2. The von Neumann bottleneck, silicon's rigid limits. So, why does all this guessing happen in the first place? Well, let's move down into the hardware to look at the rigid constraints of silicon architecture.
Pretty much all computers today are built on what's called the von Neumann architecture, which physically separates the processor from the memory. Now, for an AI that's evaluating billions of parameters, this physical separation creates a massive, grinding data traffic jam. The processor literally has to sit there, completely idle, waiting for data to be shuttled back and forth. It forces AI to burn massive amounts of energy just moving electrical currents across physical copper wires rather than actually doing the computing.
And here's the crazy part. Inside those physical copper wires, there are no semantic symbols. Actually, there aren't even really ones and zeros in the way we usually picture them in our heads. There are only continuous electrical currents marching along to the strict internal metronome of timed execution cycles. A high voltage is a 1, a low voltage is a 0. Sure, but it only matters if it happens exactly on the beat of that clock cycle. It's a relentless, unyielding mechanical grid of time.
And this creates an absolutely massive friction point. On one side, you have the fluid, continuous flow of human associative thought and the continuous vector spaces that AI models use to map meaning. But on the other side, digital computers simply cannot handle smooth, continuous concepts. They are forced to chop that continuous meaning down to fit into the strict, rigid grid of digital execution and logic gates. This modality mismatch between continuous flow and rigid grids is exactly where the illusion of meaning completely breaks down.
Which brings us to Section 3, the FPU gambler, the floating point unit. To manage this massive friction and to do complex math fast enough, computers rely on a very specific microscopic hardware component. Let's take a look.
Now, what's really interesting about this slide is the stark contrast we see between two very different parts of a computer's brain. First, we have the floating point unit, or what we're calling the FPU gambler, and it's pitted right against the arithmetic logic unit, the ALU surveyor. The gambler is wildly fast, but it relies entirely on approximations. The surveyor, on the other hand, is slower, but it delivers exact 100% deterministic mathematical truth. And right now, modern AI relies almost entirely on the wildly guessing gambler.
Let's look inside the gambler's toolkit for a second. When the FPU encounters heavy, complex math, like calculating the square root of 2 for a massive neural network, it basically throws darts at a dartboard to approximate the answer. And to make this happen incredibly fast, chip manufacturers like Intel and ARM literally burn proprietary, completely secret seed tables directly into the silicon itself. Because of this heavily guarded trade secret hardware logic, exact mathematical reproducibility across different machines is physically impossible. There's just fundamentally no hardware-level consistency.
Section 4. The wood chipper effect. Destroying provenance. As you'll see, relying on this FPU gambler has absolutely devastating consequences for modern digital operations. Let's explore exactly why.
This right here is step-by-step how data provenance gets completely destroyed by non-deterministic hardware. Step 1, the AI ingests source data. Maybe that's a copyrighted book or a sensitive financial ledger. Step 2, the FPU hardware approximates the math of that data using those secret proprietary chip tables we just talked about. And finally, step 3, because that math was just a guess and not a precise trackable calculation, the exact deterministic path of that data is lost forever.
An industry expert actually put it brilliantly, saying, the FPU basically acts like a giant blender. You know exactly what went into the blender, but you absolutely cannot reverse engineer that smoothie back into the exact fruits it came from. I love that analogy because it perfectly captures the irreversible nature of floating point approximations. It's a total one-way street.
And the legal and financial fallout from this? It's absolutely staggering. The source material refers to this as the liquidation of contributors. Think about it. When the gambler approximates data, provenance is completely wiped out. Without an exact deterministic mathematical path, we lose the chain of title. We lose the identity of the original contributors. You simply cannot build verifiable digital trust on a foundation that is fundamentally just guessing.
Section 5. The exact ALU surveyor. Deterministic hardware. Now, before you lose all hope, there is a fix. And the best part is, it's sitting right inside our computers right now.
So, the crucial point is the arithmetic logic unit, or ALU. If the FPU is a gambler throwing darts blindfolded, the ALU acts as a surveyor with a high-end precision laser. It is a fully deterministic, universally consistent hardware component. It performs exact, verifiable arithmetic without any hidden approximations. 1 + 1 is exactly 2, every single time, on every single machine on Earth. It delivers absolute, undeniable facts.
By relying solely on the ALU surveyor, we actually restore Noether's theorem to our computing systems. That's a fundamental physics principle that gives us symmetry and reversibility through absolute hardware determinism. Because there's no guessing involved, we completely avoid that 50% critical line where approximation errors aggressively compound on top of each other. By maintaining an exact mathematical ledger, we regain the power to forensically work backwards and trace the undeniable truth of our data.
Section 6. Forging forensic accountability. Verifiable digital trust. Let's take a step back and connect these microscopic hardware realities directly back to the massive real-world stakes for all of us. We are hurtling toward a future where AI is going to be tasked with incredibly high liability duties. We're talking about managing massive enterprise finances, negotiating binding legal smart contracts, running critical flight telemetry, and even operating nuclear reactors. When human lives and literally trillions of dollars are on the line, we absolutely cannot let an AI use a hardware gambler to just guess the answers. We need rock-solid, irrefutable mathematical receipts.
To achieve this level of accountability, forward-thinking developers are intentionally shifting away from the FPU. The industry is beginning to rewrite core math functions in languages like C and WebAssembly to intentionally rely solely on the exact ALU surveyor. This is a real game changer, folks. It moves our systems away from the foggy, unauditable realm of probability and steps them right into the clear, verifiable light of deterministic accountability.
As we wrap up, I want to leave you with a rather provocative thought to ponder today. If the invisible physical engines powering our entire digital world secretly rely on hidden proprietary approximations that liquidate data identities, who really owns the truth? I encourage you to always question the math behind the machine. Thank you so much for joining me for this explainer, and as always, keep learning and look past the screen.